Today we will learn about the Kafka. We have to know like right now if you are using any microservices application or architecture and or cloud application I can say, and it is like most widely used right now in the market or demanding in the market I can say. So we have to know like why it is important and why it is fast. And first of all we have to know like what is the Kafka. So I already given the basic structure of this Kafka diagram I can say. We have a producer and consumer, and this middle we have a Kafka broker, like Kafka browser, I can say. And for this, we have a communication providing with the help of topic. So in the Apache Kafka, I can say what is the basic definition we have to be know. So it is like open source stream processing platform developed by the Apache Server Foundation, and it is designed to handle the real-time data streaming and processing at a scale. So Kafka is basically known for its high throughput, durability, fault tolerance, and low latency capability. I can say most important thing, this is a major factor what we can consider: high throughput, durability, fault tolerance, and low latency. Latency is like very low. I can considering. I also work on this type of application, so I know this is very good example, or this is very good feature I can say for this Kafka. So it is widely used in various industry for scenario like real-time data analytics, event sourcing, log aggregation, and more. I can say if you are know about the stock market domain, like, and each and every day you have to be know like what is why this data is going up, which factor or which stock is going up and high. So we are like communicating with the real type of data. So on that type of application, this is very useful because there we don't need to latency problem. And coming to the features for the Kafka, we have in the Kafka we have like publish subscribe model. So Kafka follow a publish subscribe model where producer like publisher write the data to topics, and consumers subscribe and read data from this topic. That's why I can say we are having this writing and reading over there from the help of topic. And if you're not aware about the topic is like logical channel or category to which data is published, and producer send data to the specific topic. And after that, we have a partition is I can say most important factor. Like Partition allow Kafka is to distribute the data across the multiple server. It is like similar type of a thing we are doing in the load balancer. Similarly, not exactly load balancer, but yeah, it is sharding type of thing we are doing with the help of this partition. So it is like distribute data across the multiple server, enabling parallelism and scalability. That's why this partition will be important in this factor. And after that, we have a broker, and in the broker, Kafka broker serve that manage the storage and retrieval of data, and topic are divided into partition and store on the brokers. As you already seen the topics, like we have a communication for the publisher and subscriber. So that will be like we are dividing into partition and store on the broker. So that's why this broker is using in this Kafka. After that, we have a replication provider for that fault tolerance. Like if you're miss, or if you're like you are sending the data continuously, if you are miss anything on that communication, so for that purpose we already having one server which we are sending, or I can say which we are using for the fault tolerance. So that's why this replication is working here. And each partition have multiple replicas stored on the different brokers. And next we have a producer is like responsible for sending data to Kafka topics. As I already told, we are having a producer consumer. So that's why this producer is sending the data to Kafka topic, and they can specify which topic and partition to send data to. Like they have to be know like where they are sending this data. They have to be know about the destination where they are sending. So that's why it is very crucial factor when we are using the producer. Coming to the consumer part, consumer read data from the Kafka topic, and each consumer group read data independently and allowing for the parallel processing. So what the data they are receiving from the producer, consumer is consuming from the topics. Next, we have a consumer group also, and the consumer group allow multiple consumer to work together to read data from a topic. So in message, I can say partition is delivered into only one consumer, and in a group, I can say each message in partition is delivered to only one consumer in a group. So this is comes under the consumer groups. Coming to the offset is like unique identifier assigned to each message within a partition, and it is like tag type of thing which we are providing in the messages. I can say consumer keep this track of their progress using this offset. So these are the key feature when we are using the Kafka. Coming to the why Kafka is fast. Behind that we have a like very strong architecture. when you are using any application or any web application or any mobile application, and if you feel smoothly this application is working very fine, very smooth, behind that very hard work and very complex logic we are building over there. And that's why this that application will be running very smooth and very fast. For that, I can say why Kafka is fast. There is a architecture, it is a very strong point. Distributed architecture we have, and Kafka distributed architecture allow to handle the large amount of data by the distributing it across the multiple broker and partition, and this enable parallel processing and improve the throughput. That's why Kafka is, I can say, fast. This some of the like key factor, I can say, key component I'm discussing here. Because of that, this Kafka is becoming a fast. Second, we have a right optimized design. Like every application, if you are writing over there, so you have to be write the optimized code or optimized design. And that's why the Kafka is also following. Kafka is optimizing the high throughput writes, and producer can effectively write the data to topics without waiting for the consumer to read it. They are sending the continuously data, and they are not waiting for like if they are reading or not, and they are sending continuously. And we already have a like fault tolerance. If anything is missing, they are recovering from that one. Next one, we have a partitioning. As I already mentioned, partitioning is nothing but the sharding, and Kafka is partitioning mechanism allow for the horizontal scalability, like increasing servers and all. And each partition can be on the separate broker and distribute the load and improving the performance. Next, we have a replication. As I already mentioned, replication is used for the fault tolerance. So if any broker fails, replica can take over without data loss and maintaining a high availability. It's not like if data is missing over there, you are not getting your data or your result. It will be coming little bit second, I can say, with the delay, but it will not lose your data. Coming to the next, we have a sorry, batching system, and on that Kafka support batching of messages and allowing producer to send multiple messages in a single batch. And this reduces the network overhead and increase the efficiency. Yeah, because each and single message you are sending apart, rather than that you can use the one group and single batch and send the all the messages. Next, we have a sequential disk input output, and Kafka designed the minimize the random disk I/O by writing the data sequentially, and this result in efficient disk uses and faster read and write operation. That's why it is making a fast. This is a like very important component. Coming to the zero copy is like Kafka uses the memory map file and reducing the need for the copying data between the OS and Kafka, which improve the efficiency. This is a major component without like copying and all, and we are designing with the memory map file. That's why it is like reducing the copy of data between the OS and Kafka. So because of that, it improve the efficiency. And when we have a memory caching, Kafka utilizing memory caching, and for that, like we are frequently accessing data and reducing the need to fetch the data from the disk. Caching, as I already know, caching is used for the frequently accessed data, and we are using the memory caching. It means already when we have a memory caching, we are fetching the data from the memory, not from the actual disk. Then I can say overall, Kafka design and architecture, which prioritize the efficient distribution, replication, and sequential disk I/O, and contribute to its high performance and speed in handle real-time data stream. So because of this efficiency, this feature, this component, these advantages, the Kafka becomes so fast and most popular. Every company, every application, every organization trying to using this thing to become their like application or any what the services they are trying to consume it, that become fast. And if you are using the live stream or live data, I think if you are not feeling any latency problem over there, working smoothly, behind that I think that company or that organization using for their application is a Kafka. So Kafka is most important and more important to the application for the efficiency and fast working purpose. I think you got the very valuable information about the Kafka, why we are using, what is the important things, what is the major things we have to be considered when we are using, what is the advantages, what is the key component, what is the key feature. And according that, I think that's why it has become so popular and so fast. I think I already discussed the some insightful information with you. If you like it, please share, subscribe this channel. Thank you.